What comes to mind when you hear the name Nikola Tesla? Don't picture just a mad genius who loved pigeons or claimed to talk to aliens. Don't think of a man who invented the death ray yet died in poverty. Tesla's name isn't just a quirky story. It literally means electricity. And in this story, you'll see why his life made that name meaningful. Nikola Tesla is the reason the electricity we take for granted exists in our homes today. Whether it's watching television, charging our phones, or running an air conditioner, the very current powering offices, malls, and homes worldwide flows because of his genius. In Tesla's era, Thomas Edison's direct current, or DC, dominated the world. Edison had built incandescent lamps for streets, factories, and homes, but they were inefficient, prone to short circuits, and could only light short distances. They required constant maintenance in nearby power stations. Tesla changed everything with alternating current, or AC. He was the first to create a variable AC system, and his rotating magnet design allowed electricity to flow smoothly and continuously. He also introduced the idea of electric poles, enabling power to reach miles away from a single distribution hub. But AC was just one part of Tesla's legacy. Across his lifetime, he held more than 300 patents, inventing devices and systems that were decades ahead of their time. How did he achieve so much? What drove him? What fueled the mind of a man so far ahead of his peers? These questions and the story of his life are what this book explores. Tesla was born in Smiljan, Croatia, into a family rooted in farming. His father, Milutin, was a parish priest, and his mother, Juka, managed the household and farm. Their family was well off, and Nikola was the fourth of 5 children, with an older brother, Dane, and 3 sisters. As a child, Nikola was endlessly curious and mischievous. He and his brother would swim in the village pond, catch frogs, and invent little contraptions like water wheels and bird traps. He had a beloved cat named Makak, with whom he rolled in the grass for hours, laughing. One day, Nikola noticed sparks jumping from the cat's fur when he stroked it. His father explained it was electricity, like lightning, and young Nikola was fascinated. For the most part, his childhood was happy. He loved the animals, the land, and the simple joys of farm life. But tragedy struck when Nikola was 7. His older brother, Dane, fell from a horse and died. Dane had been the apple of their mother's eye, and after his death, Nikola felt neglected. This loss and lack of maternal affection stayed with him throughout his life, shaping both his genius and his neurotic tendencies. Eventually, the family left the farmhouse. His father took a job in Gospic, where Nikola began formal schooling. From an early age, he showed an extraordinary talent for physics. He experimented with batteries, motors, induction coils, and water turbines. His brilliance allowed him to finish high school in just 3 years. Shortly after, Nikola fell ill with cholera, bedridden for 9 months and nearly at death's door. Concerned for his son's future, his father, who had wanted him to become a priest, allowed him instead to study engineering. Nikola went on to attend the Polytechnic School in Graz, Austria, setting him on the path to changing the world forever. Part 2. College Years. During his college years, Tesla immersed himself in a wide range of subjects, not just chemistry, physics, calculus, and machinery, but also languages like English and French. His talent didn't go unnoticed. Professor Alla, his calculus instructor, was amazed by Tesla's speed and insight, often presenting him with complex problems just to see him work. Tesla would stay after class for hours, exploring every angle. While his primary passion was engineering, he also pursued languages, eventually mastering 9 in total. By the end of his freshman year, he had earned straight A+ grades across all subjects. Not everyone was happy with Tesla's brilliance. Some classmates grew envious of the attention he received. But a single moment in a physics class would shape the rest of his life. A direct current Gram dynamo had just arrived from Paris, and the professor explained its workings to the students. In nature, electricity is alternating, like a river that flows back and forth. The reason machines use direct current, or DC, with a commutator, is to force electricity to flow in only one direction. The professor spoke with pride, but Tesla raised his hand and asked a question that would change everything. What if we used electricity in its natural alternating form? What if we could run machines without a commutator? The question stung. To prove him wrong, the professor disconnected the commutator, and the machine stopped. But for Tesla, the seed was planted. From that day on, he became consumed with the idea of creating alternating current. He spent endless nights imagining motors that could operate without the DC commutator. By his 3rd year, Tesla had grown restless with traditional classes. He often skipped lectures, preferring to spend hours in the student lounge, playing chess and billiards with friends. His skill at billiards was remarkable, and he spent much of his pocket money on the game. Eventually, Tesla left college before completing his degree. After his father's death, he needed to support himself. Tesla found work at the American Telephone Exchange in Budapest, Hungary. There, he climbed poles, repaired lines, and applied both mechanical skill and mathematical insight. He began to understand electromagnetic induction, the idea that one object could influence another from a distance without direct contact. Outside of work, Tesla spent time with Anthony Szigeti, a former classmate and now co-worker. Tesla continued to experiment with AC, dismantling and rebuilding countless DC machines to understand the mechanics. But the obsession came at a cost. He ate poorly, slept little, and pushed his body to the brink. One day, exhausted and in severe pain, Tesla thought he would never recover. Szigeti encouraged him to take a walk for exercise. It was during one of these walks that inspiration struck. Tesla suddenly understood how to make AC work. He immediately sketched the idea on a piece of wood, what would later become known as the magnetic field rotation diagram. In simple terms, DC sends electricity through a single circuit. Tesla's AC system used two circuits. He imagined rotating circles stacked atop each other, each with magnets positioned 90 degrees apart. Through induction, each magnet influenced the others, spinning electrons regardless of whether the charge was positive or negative. He could see motors running in his mind, then translated that vision into diagrams and equations in his notebook. Soon, both Tesla and Szigeti received job offers from Edison's Lightning Company in Paris, a chance they eagerly accepted, stepping into the next chapter of Tesla's extraordinary journey. Part 3, Tesla meets the Wizard of Menlo Park. In the 1880s, Thomas Edison's incandescent lamp was revolutionizing the world. Before it, homes, streets, and railroads relied on flickering gas lamps. Edison's steady, bright light transformed daily life across America and Europe. Tesla, seeing the glowing streets of the city for the first time, was captivated by the energy and possibilities of urban life. In Paris, Tesla began working for the Continental Edison Company under Charles Batchelor, who had recognized his exceptional talent. Soon he was sent to New York and placed at the Ivy-sur-Seine factory, where light bulbs and generators were produced. Tesla quickly earned respect for his expertise, installing lighting in opera houses, theaters, railroad stations, and cafes. His work also took him across Europe, to Paris, Bavaria, and Berlin, refining his understanding of electricity. By 1883, Batchelor assigned Tesla to oversee the installation of electric lamps at the Strasbourg plant. Even with these responsibilities, Tesla continued developing his alternating current project. With Szigeti as his assistant, he constructed a disc wrapped in coils mounted on a needle. When he flipped the switch, the disc rotated, generating AC, a glimpse of his vision coming to life. In 1884, at 28 years old, Tesla arrived in New York. The Brooklyn Bridge had just opened, the Statue of Liberty gleamed in the harbor, and Edison's lamps illuminated Menlo Park, home to some of the city's wealthiest citizens. Edison had earned the title Wizard of Menlo Park for powering Central Station, Wall Street buildings, and even J.P. Morgan's mansion and office. Finally, Tesla met Edison at his laboratory near Central Station. Their first conversation was unusual. Edison joked about Tesla's birthplace near Transylvania, asking if he had ever eaten human flesh. Despite the odd introduction, Tesla greatly admired Edison for accomplishing so much without formal education. But admiration quickly gave way to insight. Tesla noticed Edison's reliance on trial and error, a method that often led to mistakes and wasted effort. Tesla, with his strong grounding in physics and mathematics, saw a more efficient path. Calculations and theory could simplify invention. To Tesla, Edison's approach sometimes felt like searching for a needle in a haystack. Still, Tesla respected Edison's genius. He continued installing lamps, repairing DC generators, and improving regulators, arc lamps, and commutators, patenting his enhancements along the way. He even proposed an induction AC motor to Edison, but it was rejected. Edison had promised Tesla $50,000 for redesigning crucial equipment. When Tesla completed the work and asked for his payment, Edison laughed. "You're still a Parisian," he said. "You'll never appreciate an American joke." Disillusioned, Tesla left the company, ready to follow his own vision. Part 4, Liberty Street and the Birth of AC. After leaving Edison, Tesla encountered two businessmen, Robert Lane and B.A. Vail, who promised to help him launch a lighting and manufacturing company in Rahway, New Jersey. They assured him that his name would be on the company, he would hold stock, and most importantly, they would support the development of his alternating current motor. Trusting them, Tesla agreed. For several months, Tesla worked tirelessly, installing arc lighting systems across the town, illuminating factories, streets, and public spaces. His engineering brilliance earned praise, and his work was even featured in Electric Review magazine, including an advertisement for Tesla's lighting and manufacturing company. But once the project was completed, Lane and Vail betrayed him. They abandoned Tesla, taking the credit for his work and leaving him without funds. Focused entirely on his inventions, Tesla had no time to manage finances and found himself taking desperate measures to survive. He became a ditch digger, earning just $2 a day. The foreman, surprised by Tesla's intellect and demeanor, eventually introduced him to Alfred Brown, a company engineer impressed by Tesla's lighting project. Brown immediately recognized the limitations of direct current. DC was inefficient, prone to sparks and short circuit. Seeing the potential of Tesla's AC system, Brown approached lawyer Charles Peck to help finance the project. To persuade Peck, Tesla told the story of the egg of Columbus. The legend says Columbus challenged critics to make an egg stand upright. When they failed, he cracked the bottom and stood it up, proving that a seemingly impossible task could be done with insight and creativity. Tesla asked Peck if he would support him, just as Queen Isabella had supported Columbus. Peck admitted he didn't have a fortune, but could connect Tesla with people who could help. To demonstrate his concept, Tesla boiled an egg, then had a blacksmith create a brass and iron version. Back in his lab, he placed the metal egg in the center of an AC polyphase circuit. When he turned on the electricity, the egg began to spin. At first, it rotated slowly, but as the speed increased, the egg stood upright. This simple yet striking demonstration of the rotating magnetic field convinced Peck of Tesla's genius. With Peck and Brown's support, Tesla founded the Tesla Electric Company, establishing a laboratory at 89 Liberty Street. Tesla shared his patents equally with Brown and Peck, including AC dynamos, motors, commutators, and power transmission inventions. He was now at the peak of his career. Over the next 15 years, Tesla continuously created groundbreaking inventions, developing single-phase, two-phase, and three-phase AC systems, and even experimenting with four-phase and six-phase currents. When his longtime friend Anthony Szigeti joined him in New York, he became Tesla's assistant. Tesla was the visionary designer, Brown the technical expert, and Szigeti the supporting engineer. Together, they manufactured the first AC induction motors, while Peck raised funds from investors and bankers. T.C. Martin, editor of Electric Review, visited the lab and was impressed by Tesla's precision and skill. He encouraged Tesla to present a lecture at the American Institute of Electrical Engineers. In May 1888, Tesla unveiled a new alternating current motor to an astonished audience. He demonstrated that AC systems could operate without short circuits, and that precise calculations could determine the spacing of electric poles. Tesla's AC induction motors could transmit electricity miles from a single distribution center, making electricity not just a source of light, but a way to power machines and appliances. Experts validated Tesla's system, and his lecture caught the attention of George Westinghouse, a talented engineer and businessman in Pittsburgh. Westinghouse had quadrupled his company's sales in a single year and had been searching for a reliable AC motor. After visiting Tesla's Liberty Street lab and seeing the induction motor in action, he was convinced of its potential. But time was critical. Westinghouse needed to act quickly before another investor claimed Tesla's AC patent. Part 5. Induction at Pittsburgh. In July 1888, Tesla finally met George Westinghouse. They reached an agreement. Tesla would receive $5,000 in cash up front, $20,000 every 6 months in notes, and $2.50 per patent royalty. Additionally, if Tesla assigned his patents to Westinghouse for a year, he would receive $5,000 the first year, $10,000 the second, and $15,000 thereafter. Tesla began working as a consultant in Pittsburgh, teaming up with Westinghouse's engineers to develop AC induction motors. He took no professional fee, only royalties. During this time, he stayed in a hotel in Pittsburgh, fully immersed in his work. But his time with Westinghouse lasted only a year. The business competition grew fierce. Edison continued promoting direct current, which could not transmit over long distances without a commutator. To protect his market, Edison and his associates launched a public campaign against Westinghouse, Tesla, and AC motors. One of Edison's allies, H.P. Brown, conducted cruel experiments to portray AC as dangerous. Dogs were subjected to increasing voltages. 300 volts made them bark, 700 volts caused struggle, and 1,000 volts resulted in death. Later, AC was even used in the electric chair, creating fear and damaging Westinghouse's reputation, stock value, and sales. Under pressure, Westinghouse asked Tesla to remove the $2.50 royalty condition to save the company. Tesla agreed, but the work on AC induction motors continued. Financial challenges persisted, and investors threatened to remove Westinghouse from the presidency. For a time, AC motor development was halted, and Tesla returned to New York. During his Pittsburgh period, Tesla faced technical challenges as engineers suggested low-frequency AC to improve compatibility. His only assistant there was Charles Scott. After 2 years of inactivity, Westinghouse's engineers resumed work on Tesla's AC projects. Despite false claims from others, including Benjamin Lemmy, that they had invented low-frequency AC, it was Tesla's designs that succeeded. His mechanisms were later widely copied across Europe and America. Part 6. The Royal Society. In 1891, Tesla patented the mechanical oscillator, a versatile machine capable of producing a smooth, continuous current. It could generate millions of volts, and its frequency could be adjusted at will. That same year, he formed a friendship with British scientist J.J. Thomson, the man who had discovered the electron. Tesla also patented a condenser, an electric meter, and tools for incandescent lighting. He traveled to London to deliver a lecture at the Institute of Electrical Engineers titled Experiments with Alternating Currents of High Potential and High Frequency. Many prominent scientists attended, including Thomson, all amazed by Tesla's visionary ideas. Speaking to the audience, Tesla said, "Is there anything more interesting than alternating current for study? This energy can take any form: mechanical, light, heat, and even chemical energy." He then demonstrated his Tesla coil. Electricity leapt like miniature lightning bolts, and he performed what seemed like magic for the audience. Lamps on stage lit without wires, and glowing phosphorescent lights shone in different colors. In one striking demonstration, Tesla held a wire connected to the coil in one hand and a glass tube in the other. Electricity traveled through his body to light the tube. He repeated similar experiments, leaving the audience awestruck. He concluded by explaining that wireless communication was nearly complete, and soon messages could cross the Atlantic using Morse code or flashes of light. The Royal Society audience had never seen anything like it, and they eagerly asked for more. Tesla gave a supplementary lecture, answering questions about how he could handle such high current. He explained that he only increased the frequency of the current, not its power or amplitude. To prove it, he set the machine to tens of thousands of volts, touched a wire with one hand, and held 2 fluorescent tubes in the other. The tubes glowed instantly. "As you can see, I am alive," Tesla said. When asked if it hurt, he replied that he sometimes felt sparks on his hands, slightly burning or peeling the skin, but nothing more. Holding a small conductor in his hands even prevented that. After London, Tesla demonstrated his experiments in Paris, where French newspapers praised his skill. He met dignitaries including Prince Albert of Belgium. Tesla then returned to Croatia for his mother's funeral, visited family, and gave a lecture at Zagreb University. His travels continued through Budapest, Belgrade, Berlin, and Bonn. In Belgrade, he met the young King Alexander and was awarded the Grand Officer of the Order of St. Sava, father of the wireless. Back in New York, Tesla's new base was the Gerlach Hotel, near the newly built Madison Square Garden. The hotel featured electric lighting, a working elevator, and grand dining room. Tesla would walk daily from the hotel to his laboratory on South Fifth Avenue. He became an official member of the Royal Society of Great Britain and a celebrity wherever he went. One day, George Westinghouse visited Tesla to discuss the AC system. Westinghouse had been tasked with powering the upcoming Columbian Exposition and asked Tesla to help with the setup. Though Westinghouse remained cautious about AC, Tesla assured him it could work efficiently, even without brushes or commutators. Collaborating with Westinghouse's engineers, Scott, Schmid, and Lemmy, Tesla helped design new machines, including a large dynamo. In turn, the engineers assisted Tesla in building an exhibit under Westinghouse's banner. To protect Tesla's inventions from competitors, Westinghouse declared him the sole inventor of the AC polyphase system. The company secured exclusive rights to reproduce and sell Tesla's AC inventions, with plans to harness hydroelectric power from waterfalls. This vision ultimately transformed Niagara Falls into a center of hydroelectric power, a feat only possible because of Tesla's work. Edison had also bid for the project, but his DC water wheels required nearby power stations to operate. Today, a statue of Tesla stands at Niagara Falls, honoring the man whose genius lit up the modern world. Part 7. Loose Ends. In 1899, a young engineer outpaced Tesla in transmitting wireless communication across the Atlantic. Italian inventor Guglielmo Marconi successfully sent the letter S in Morse code, capturing attention across America and Europe. For Tesla, who had dreamed of connecting the Atlantic, this was a setback. His vision was far grander. He wanted to connect the entire world. With support from banker J.P. Morgan, Tesla began constructing the Wardenclyffe Tower on Long Island, a structure similar to today's cell towers. He invested nearly all his wealth into the project, sacrificing almost everything he owned. Yet Marconi's earlier success caused Morgan to withdraw his backing. Despite Tesla's tireless efforts, success remained just out of reach. Some say the struggle contributed to a nervous breakdown. In his later years, Tesla found comfort in feeding pigeons in the park. Birds would even visit his hotel window. He had a special bond with a white pigeon with black-edged wings, treating it almost like a human companion. Tesla never married, nor did he have children. He believed his celibacy allowed him to focus entirely on his work. When the beloved pigeon died, he felt a profound sense of completion, as if his life's purpose had been fulfilled. Tesla passed away a few months later at the age of 86. His body was discovered in his hotel room, and the official cause of death was coronary thrombosis, a blood clot in the heart. First Lady Eleanor Roosevelt wrote, "The President and I are deeply saddened by Mr. Nikola Tesla's death. We can never forget his contributions to science, industry, and this country." Approximately 2,000 people attended Tesla's funeral, honoring the life of a man whose work quietly shaped the modern world. The Wizard's Legacy. Tesla's contributions continued to be celebrated long after his passing. In 1956, on the 100th anniversary of his birth, a special commemoration was held. Nobel laureate Niels Bohr delivered the keynote, recognizing Tesla's extraordinary impact on science. Yugoslavia issued a Tesla stamp and featured his portrait on the 100-dinar banknote. Statues were erected in Vienna and Zagreb, and a school in Illinois was named in his honor. The Institute of Electrical Engineers named the unit of magnetic flux, the Tesla, after him. In 1976, Yugoslavia gifted a statue of Tesla to Niagara Falls, honoring his role in harnessing hydroelectric power there. Additional monuments stand in Gospic, Croatia, where he spent his childhood. A large Tesla coil is displayed at the Boston Museum of Science, and New York hosts both the Tesla Memorial Society and the International Tesla Society. Tesla's ashes are preserved in a gold-plated urn at the Nikola Tesla Museum in Belgrade, Serbia. Conclusion. This summary introduced Nikola Tesla and his pioneering work with alternating current, magnetic field rotation, and wireless energy. You've learned about his rivalry with Thomas Edison, his collaboration with George Westinghouse, and his inventions, from mechanical oscillators to the Egg of Columbus and wireless communication. Tesla's ultimate vision was to reduce human labor, freeing people to pursue creativity, innovation, and intellectual growth. He dreamed of a world where machines handled the mundane, giving humanity the time to achieve higher purpose. Next time you use a washing machine, elevator, or any modern appliance, pause and reflect. Are you honoring Tesla's vision? Are you dedicating your time and energy to something creative, intellectual, or meaningful? Tesla left this world hoping that people would carry forward his vision. Let us not let him down. The man who sacrificed comfort, wealth, and personal life gave us efficient electricity and a path toward a better future. Let us promise ourselves today to create, innovate, and move forward so we can live more purposefully and appreciate the visionaries like Tesla who made our modern lives possible.